Hello, welcome to India's most comprehensive e-learning platform, Byjus Exam Prep. We all have gathered together as a part of the discussion related to the Champion series, and currently we are discussing about the special subject, that is measurements. Of course, this is a second class in the measurement subject. Already I have handled the first lecture in yesterday exactly at 7 p.m. and the topic was 2-watt meter method. And today we are going to discuss one more important topic in the measurement subject. And as you guys are very much aware of the today's lecture, we will going to discuss majorly about watt meter is completed. We are going to discuss about energy meter, because whenever I speak with the instrumentation students and especially with the electrical students also, watt meter and energy meter, these are the two topics they always feel some difficulty. So that's why I come up with a better way to deliver the concept of energy meter, and I'm very sure if you are with me till the end of the whole session, definitely you will going to understand energy meter in a very simple way, and finally you will appreciate my class as I am not going to discuss anything as a formula based. Clear? So those students who are regularly attending the class, they might be very aware of the situation that I use the formulas very less, but we will try to solve every possible question only through the concept. Clear? So Rajshekar, good evening. After a long time I am able to see you. Isha Agarwal, good evening. Right. Moving ahead, before going to start the session, let me quickly introduce about myself. As you all can see, myself Phanindra, all put together, I have an experience of 12 plus years teaching experience, and if you can see, the most fascinating thing about myself is up to now I have guided more than 50,000 students in the subjects of control system, circuit theory, and even measurements and industrial instrumentation. Clear? So let me quickly explain about the today's topic, that is energy meter, but you must keep the schedule in your mind. As I said already, we have done with the first topic. This is already completed to every one of you, and if any student missed the topic related to 2-watt meter, I sincerely suggest please go and watch the previous lecture. Very important topic we had. Correct? And today we are going to discuss the second topic, that is energy meter. Of course, based on the student's choice, I have changed the third topic as Q meter. That also we will going to discuss after, in fact, in tomorrow's session sharply at 9 p.m. So let's start the discussion of the day here, that is energy meter. So the first question in the energy meter, what I do is, let's move differently because we are in the champion series. So I was asked to discuss about the questions. What I will do is, I will take the question and concept parallelly such that from the starting to ending, if you are with me, you will understand the concept of energy meter so clearly. Clear? Right. So energy meter works on dash principle. So it's very simple question. Of course, those students who are with me, in fact, who attended my classes, you can easily answer this, right? So this is the way how energy meter looks like. There are several elements and components here, right? So starting from the voltage coils and copper shading ring, current coils, and in fact, we have a gate, train, dials, and magnet brake and all these things. Of course, we have a rotating aluminum disc exactly in between the current coil and voltage coil like this. Clear? And this is very important part of the whole energy meter. Now, those students who know the answer, you can directly go and pick up the answer. But as I said, my intention is to explain the concept behind this. So let me take some time to explain here. Suppose the same diagram, whatever is visible here, if I keep that as an electrical representation instead of the disc and all these things. Suppose if you look at the front view, this circular disc, how it looks like? It looks like a straight line to you. Correct? So front view of a circle, suppose if you have a circle like this, if you look at the front view, it looks like a circle, a straight line. Correct? So therefore, this straight line here, whatever you can see, all the way this is considered as a disc here, and the disc is actually pointed with the magnet here, and this is called as a bar magnet here. See, we have a magnet here, correct or not? Magnet brake, because this is the one which will going to apply the control torque here. So therefore we call that as a magnetic brake. Now the same thing here I have placed here. Correct? So just above this aluminum disc, we have voltage coil which is called as a shunt coil here, and current coils here, this and this together they will be called as a current coil. So what I do is, first I will explain the basics here. After that we will see the working of this one. Clear? Moving ahead, look at this. where we are having the shunt magnet here. So obviously the shunt magnet is very clearly visible to you, isn't it? So everyone must answer this one. So we have a pressure coil here and the current coils are here. So this is current coil, let me say, and this is current coil. Of course, this is simply called as a pressure coil here. Clear? Current coil, and this is current coil. Now the most beautiful thing here is we are going to take, or we are going to apply single phase AC supply here. So let me write down this as a single phase AC supply. And interestingly, this single phase AC supply is connected to a load like this. So for time being, let me take any electrical load. Okay, you guys might be better knowing about this. So if I take electrical load here and connect the electrical load in between the positive supply and negative supply here, so what you will going to get here? So let me write down clearly here. So let us take this as load, or we can even take this as a ZL, that means load impedance for time being, and assume that it may be having some phase angle. Okay, it may be having some phase angle. Now all put together we have a load which is connected between these two terminals. Now is it looking like, suppose in case if the AC supply delivers the current here, so assume that AC supply is delivering the current, and quite logically the current has to flow. There will be some current that will flow through the pressure coil definitely, but load current, if I say IL here, look at that, how the load current will be flowing. IL will be flowing like this, and all the way IL will be coming like this, and this is going to be IL here, and the same current is flowing here, IL, and I am very sure the current will all the way pass through the current coil here. So please see here, current coil here, and then all the way it will circulate, and finally it will come to the negative terminal of the AC supply here, correct? So that means it is the coil or current coil current, or the current flowing through the current coil is equal to the load current, correct? So for time being, let me write down here, the current flowing through the current coil is itself, it is going to be the load current. Clear? So IC stands for the current flowing through the current coil. Clear? Current flowing through the current coil. Now at the same time, you can see there is some amount of current that will be flowing through the pressure coil also, of course. And here pressure coil, we intentionally make this as a highly inductive. Highly inductive. Why it should be highly inductive? That I will explain naturally in the discussion. But look at that. This current will all the way circulates like this, and finally it will come back like this. Clear? So now if you look at, what can I say is, you are having the single phase supply like this. So let us say the single phase supply all the way like this, and here we have a current coil here. So let us say current coil is all the way here, and here you have impedance, let us say ZL, load impedance, and here we do have again a pressure coil here. So let us say the pressure coil is like this. Now exactly I can say pressure coil voltage is the voltage across the load ideally, and the voltage across this one. But we assume that the voltage drop across this coil is almost equal to 0. Then the pressure coil here, straight away I can say this is across the load. So indirectly what I mean to say is, again it is like a wattmeter connection only, correct? So that means we are trying to take the load current, and we are also trying to measure the load voltage by using the potential. In fact, one second, by using the pressure coil, we are trying to find out the voltage across the load, and by using the current coil, we are trying to find the current through the current coil. But what was the question? Have you remembered the question here? Energy meter works on dash principle, correct? What happens here is, whatever the current that is flowing through the current coil here, IC, the current which is flowing through the current coil, naturally it will going to create some kind of flux here. So let us say the flux created by the current coil is phi C here, and this flux which is created by the current coil, again that will be linked to what? So look at that, we have here, obviously the flux will come like this, correct? So this is the current coil, so the flux will come like this. So therefore we can see in the aluminum disc, we are going to have some magnetic flux. In fact, the magnetic flux is flowing through the aluminum disc, and the aluminum disc is rotating like this, correct? Aluminum disc, you can see the previous diagram, aluminum disc can all the way rotate like this. Now the beautiful point is, as the aluminum disc is rotating inside the magnetic flux created by the current coil, we will be having the eddy current introduced by the current coil. Clear? I repeat, eddy current introduced by the current coil. This is very important to understand. Now similarly, the potential coil current, whatever is flowing in the potential coil, that will also create some amount of the flux here, but it will be in the downward direction, correct? So this is the way it will going to indicate. The flux will all the way come like this, right? Even this flux also links with the disc, aluminum disc. As the aluminum disc is rotating continuously, again eddy current will be developed because of this flux also. Because you might be knowing this one, right? Whenever the conductor actually rotates inside the magnetic flux, eddy EMF will be developed. Because of that eddy EMF, eddy current will be developed, correct? So therefore, what should I write here? The potential coil will also deliver some kind of flux, that is a flux introduced by the potential coil. As this flux is linked to the rotating disc, eddy EMF will be generated, and that will introduce the another current called eddy current here. Clear? So now the most beautiful point here is, look at that. Suppose if you have an aluminum disc like this, all of you should listen here clearly. Aluminum disc all the way like this. This is a circle. What happens here is, when the current coil is actually pumping the magnetic flux from the bottom, let us assume that we have an aluminum disc all the way like this, and the current coil will actually send the magnetic flux from the bottom, right? But you must understand that there will be eddy current that will be developed here, and that current, eddy current, will be in this direction. So let us say this is going to be the eddy current because of the ICE, that means current coil. So if this is the direction of the current, eddy current here, now can you tell me if this is in the, like a loop, what will going to happen? Now because of the eddy current, the magnetic flux will actually come in the opposite direction to the magnetic flux that is created here. This is magnetic flux created by the phi C. Clear? This is magnetic flux created by the current coil that is all the way coming from the bottom of the disc. At the same time, the eddy current which is introduced inside the disc, that will create the magnetic flux opposite to the original flux here. Clear? So that means ICE will act in opposition to the flux created by the current coil. Clear? This is called Lenz's law, and the overall process is called induction. Now what about the other side? Other side, if you look at clearly, look at that. Other side, we have the pressure coil current like this. So that means phi P is coming from the top. So if it is the aluminum disc, phi P is coming from the top. Now the most beautiful point here is, because of this phi P in the aluminum disc, as I was saying that this is considered as a aluminum disc here. Now we will be having one more current here, and in fact this current, now I should say all the way, right? So this is going to be the current, in fact it is the opposite, and this current is actually nothing but the eddy current introduced by the pressure coil here. So this is the eddy current introduced by the pressure coil. Soumya Bal, good evening, right? But I am explaining the most important concept. Soumya Bal, try to understand and let me know how the induction is happening here. So the flux which is created by the current coil is coming from the bottom. Clear? It is coming from the bottom. Disc is here, and whereas the flux is going from the bottom to top and the disc is rotating, inside the disc we are going to have this current, and that is called as a eddy current. Now similarly, the flux created by the potential coil is acting in the downward direction, and that is creating another eddy current. This will be in the reverse way, and most important thing is this current will create the magnetic flux in the upward direction. Clear? So that means the eddy current here creates the flux which is opposite to the original flux, that is phi P. Is it clear to all of you? Yes, Soumya Bala, good evening. Are you able to understand the concept of induction here? So see, there are two eddy currents which are developed, and both of these two eddy currents will going to oppose their parental flux. Clear? Parental flux means what? This current created by eddy current created by the current coil has a parent here, that is nothing but flux because of the current coil. Clear? And eddy current created by the pressure coil has a parental, that is flux P. But the interesting fact here, if you see, there are two fluxes that are in support here now. Now what are the fluxes? They will be in support now. Can you see? So here this flux, whichever is created by this and this, both are in support. Correct? Both are actually in the downward direction. Right? That means there will be some torque that is developed because of, torque is a function of now because of what? That is definitely because of the phi P, that is flux because of the pressure coil, and eddy current that is developed by the current coil. Clear? there is some torque because of that. At the same time, there will be another torque tau d2, which is the function of, now look at the other side of the flux here. This will be very interesting. What is the other torque you can get here? Any one of you? Soumya Bala, can you tell me? What is the other torque here? If you are with me, you need not to use any formula here. Okay. So the other torque here is created by the upward one. Upward flux is this, and along with that we have IPE also, correct? So therefore it could be written as phi c plus IPE here. Clear? So now what happens is one torque and tau d1 and tau d2 both will going to act in the opposite direction. Therefore the net torque is usually written as a TD, which is equal to TD1 minus TD2. Clear? What is the formula exactly behind this? If you want to know, I sincerely advise you guys, please go through my regular lectures in Byjus exam prep, then you will understand the exact derivation behind this. But as of now, you must understand how the electromagnetic induction is taking place, and finally we are getting a deflecting torque here. Clear? Deflecting torque. Therefore, the deflection of the disc here is possible with the help of what? With the help of electromagnetic induction. Option B is the correct answer here. Now the crazy part here is, we all know that the deflection torque here, TD, definitely it will be directly proportional to, or it will be equal to some constant into V RMS into I RMS into cos phi, where V is nothing but the RMS voltage, I is nothing but the RMS current, and cos phi. And similarly the controlling torque here, it is purely related to some constant, I should say K dash into N. Clear? And the controlling torque is usually provided by the magnet brake here. Now if you equate it to both, then you will going to get N is equal to Vi into cos phi here. Of course people do say that at steady state the deflection torque and controlling torque both will be same, isn't it? So I expect that you people are champions, means you already know the concept here, right? TC must be equal to TD here at steady state. Therefore finally I can say the number of revolutions are somehow related to the power here, active power, or we can say active power across the load. And if you integrate both sides, that means number of revolutions taken for particular amount of time, then you will going to get here Vi into cos phi. Of course it would be multiplied by dt here. Clear? And this is considered as energy, which is nothing but W. Soumya Bal, please let me know, is it clear to you? And Isha Agarwal, Rajshekhar, is it clear to all of you? So it is considered as an energy. So therefore energy is nothing but integral of the power into dt. Integration of power is considered as a energy. Soumya Bal, is it clear? Right. Moving ahead to the next one, that is energy meter is a dash kind of instrument. Don't think that this is the standard of the question. Okay. So as we are discussing about the basics, I am clearly explaining the concept behind this, because many of the students, they don't know exactly how the induction takes place. That's why I have explained. Now here energy meter is dash type of instrument. Obviously the option is recording. Why? Have you ever used the energy meter in your home? When you use your energy meter in your home, depending upon the electrical power you are consuming, it will make the number of revolutions. Correct? So why it is so? Suppose let us say energy, as I said, energy could be written here as equal to the amount of work done, or else we can simply say that P into dt here. Correct? Integration of P into dt. Right? And interestingly, this P is actually nothing but Vi into cos phi, RMS value of the voltage across the load, RMS value of the current that is flowing through the load into cos phi. Of course, this is considered as dt here. Clear? Now you should ask a question to me, how the number of revolutions here can give the value of, any one of you, how the number of revolutions here can give the value of the energy consumed? So simple to understand. Suppose let us assume that the time is fixed. For example, if I say 0 to t, t might be the time, it may be 30 days or it may be 1 day, right? So then what is the total energy? How can I write this one now? Energy equal to the total power into 0 to t, that means it is equal to t. Correct? So what people do is, in general, electricity board people, that means electricity board people, state electricity board people, what they do, they will fix the time here. Sometimes usually this time in our home is going to be 30 days. Every month we are going to get electricity bill. Correct? right? Good evening, sir. Yes, good evening, mystery mind, right? So 30 days is the time, regular interval of time. Now, if the time is fixed, assume that for everyone, that means there are two persons here. Let us consider that he is the person 1 and he is the second person here. So there are two persons here, as I was saying, right? For both of these two, the energy will be calculated in 30 days only, correct? 30 days here and 30 days here. But in the person 1 case, we are seeing very less number of revolutions, whereas in the second person has a great number of revolutions here, correct? What does it mean? Here, if I say energy consumption is more, energy is high, energy consumption is more, and here energy consumption is less. What does it mean? What is the meaning of this? It means that the second person consumed more energy compared to the first person. Second person, in his house, he consumed more amount of energy compared to the first person. In that case, can you tell me where the power consumption is more? Gurumurthy, where the power consumption is more now? Power consumption is more in the second case, right? Because the time is fixed. So if the energy consumption is more, it means that the power consumption should be high. Clear? So it means with the help of energy calculation, we are actually looking at the power consumption. So if the time is fixed and if the energy consumption is more, then I can say the power consumption is more. Clear? So I hope this is clear to every one of you. Murthy, Mystery Mind and Soumyabala, Isha Agarwal, please let me know, is it clear to all of you or not? Now let's move on to the next one. And why it is called as recording? So if you see, the data here always getting updated. 1535, 1536 like that. That means from the previous value it is getting increased by 1. From the previous value it is getting increased by 1. What does it mean? It means it is recording the previous data and moving forward to the next data. Clear? That's why it is called as a recording type instrument. Now let's see one of the very good question here. Of course, from now onwards every question will be good question only, and I will solve, as I promise you, I won't solve any question with the too much of hectic formula. Let's use the basics and try to solve any question here. Okay? Soumyabala, what is the answer for this question? Every one of you. An energy meter having a meter constant of 1200 revolutions per kilowatt hour is found to make 5 revolutions in 75 seconds. The load power is dash. Clear? The load power is dash. So 1200 revolutions per kilowatt hour. So whenever these kind of questions are given, take the data here first and feel confident. So 1200 per meter constant is what? First write down like this. Given information, I could say meter constant all the way it is equal to 1200 revolutions per kilowatt hour here. Correct? Kilowatt hour. Right? 1200 revolutions per kilowatt hour. Now wait for 2 minutes and try to see clearly here. When it is 1200 revolutions per kilowatt hour, what does it mean? It means that if the load consumes 1 kilowatt power, in 1 hour time, clear? In 1 hour time, the meter is, or the disc is able to make 1200 revolutions here. Clear? This is the meaning of meter constant. Soumya, what is the answer? Mystery Mind, what is the answer? 1 kilowatt power consumption in 1 hour time can make 1200 revolutions. But this is a meter constant. Means it is the capacity of the meter. Meter can do like this. I repeat, meter can do like this. But what was the question? He is saying that 5 revolutions are made in 75 seconds. Okay. So 5 revolutions are made in 75 seconds. Okay, fine. So 75 seconds. It is a given information, right? So it is given information. So let us try to understand what exactly it is. 75 seconds, 5 revolutions are made. Can you please tell me in 1 second how much it will be now? 1 second, it will be 5 divided by 75 revolutions. Correct? 5 divided by 75 revolutions. Now look at what will happen for 1 hour time. Clear? 1 hour time means how much we can say? 3600 seconds here. Correct? 3600 seconds is nothing but 1 hour time. So how much it will become now? 3600 into 5 divided by 75 revolutions. Correct? 5 divided by 75 revolutions. See, we are not using any formula. Rather, we are using the basic common sense here. Correct? So wait 1 second. Yes, 5 divided by, I can say it is going to be 5 divided by 75 revolutions here, right? What happened here? 1 second. 1 second. Yes, 1 minute. Yes, good. Yes. Now we can see here there is small mistake here. Just give me 1 second. I think the system is getting updated here. So anybody got the answer? Element 240. Somebody got very good answer. That is 240. Fine. We'll see whether 240 is correct or not. Just give me 1 second. I don't know what is the reason. My pen is not working here. So suddenly. Right. So what we should do here? So you will be getting 3600 into 5 divided by 75. What would be the answer for that one? Can anybody say what is the answer for that? So 3600 into obviously I can say 5 divided by 75. Undoubtedly we are going to get 240. X, very good. 240 is the number of revolutions here. What happened here? 1 second. Just give me 1 second. Yes. Now aa gaya. Right. Extremely sorry guys. So it is going to be 240 revolutions here. That means after this much of work we got that 240 revolutions. It means that in 1 hour time with this speed the present disk, when it is connected to the load, it is able to make 240 revolutions here. So therefore conveniently what should I write here? Now look at the data which is given to you. That is very important. 240 revolutions it is able to do. When it is able to do? In 1 hour time. Clear? In 1 hour time. If it is making like this, what does it mean? How much power should be there here? So that means the time remains same. That is like with the original constant of 1 hour. But revolutions are decreasing. If the revolutions are decreasing means, what does it mean? The power which is using here or the power which is consumed here, that is reducing. How much it is reducing? Have you seen here? 1200 to 240 it is came. How it is coming? 1200 to 240 it is coming means it is 1/5 of that, right? So that means 240 is equal to 1/5 of 1200 revolutions, correct? Simple. So similarly here we should have a power here and that power should be equal to 1/5 of 1 kilowatt here. So therefore that is equal to 1/5 of 1000 here, which is equal to 200 watt here. Clear? So the answer for this question is equal to 200 watt. Option C is the correct answer. Have we used any formula here? Did you use any formula? We haven't used any formula. We just gone with the basic math. I will repeat this statement because there is some obstruction that is happened here. So this is the capacity of the meter. This is considered as the capacity of the meter. That means really if the meter at calibration, when it consumed 1 kilowatt power or 1 hour time, it can make 1200 revolutions. It can make 1200 revolutions. It doesn't mean that it will make 1200 revolutions when you connect this energy meter in your home. It doesn't mean that. It doesn't mean that. It can make that much. But when I take that same energy meter and when I keep in my home, right? So see what is happening here. 240 revolutions only it is making. Right? Why it is 240 revolutions? Because the time is 1 hour. Time is 1 hour, but the number of revolutions are less. Why it is less? Because the power consumption is less. Clear? How much is less it is? Because the number of revolutions are actually 1/5 of the revolutions that it can make. So the power also 1/5 of the actual power it should take. Clear? So that is the way how you can understand the question. Now to make it very clear, what I do is, let me go to the next question so that here you will understand this in the better way, right? So now look at that. A single phase energy meter is operating on 230 volt to 50 Hz supply with a load of 20 ampere for 2 hours time at a unity power factor. The meter makes 1380 revolutions in that period. The meter constant is dash. Good question. So let us see what is the meter constant here. Now the best part is calculate the total power here now. Total power is Vi into cos phi. This is simple. Unity power factor means it is equal to 1. So unity power factor means it is equal to 1. Clear? Cos phi is equal to 1. Direct, that is V into I. What should I say? V is a 230 volt RMS voltage. I is nothing but the load current, that is 20 ampere. It is also given here. So into 1 here. So 230 into 2. So it is 4600. In fact, the total power consumption now I can say which is equal to 4.6 kilowatt here. Clear? 4.6 kilowatt here. Now Sam Yabal and what is the Clement Aldo, both of you have understood the previous question? If so, please let me know first. Yes, right? So now moving ahead, 4.6 kilowatt is the power. In fact, that is the total power consumption. Consumption. Now what is the total time here? Total time is nearly equal to 2 hours. And how many revolutions it is making? Number of revolutions, capital N here, that is equal to 1380 revolutions here. Clear? Number of revolutions equal to 1380. Now the most beautiful point, what you must understand here is 4.6 kilowatt power in 2 hours of time. 2 hours of time, it is making how much? 1380 revolutions. Excellent, very good. Nobody can deny the fact here, correct? Now the same question I will ask different way. 4.6 kilowatt power, if I consume only, if it is consuming only in 1 hour time, what is its value here, right? So that means time is reduced. If time is reduced, then the number of revolutions must also reduce, because the number of revolutions is related to the power consumed as well as the time taken. If the time is reduced, then number of revolutions must be reduced. Please answer to my question, Soumya Bala and Clemendo. So 1 hour, how much it will be here? Can you tell me here? How much it will be? 1380 divided by half, right? So divided by 2. So it is equal to 690 revolutions, isn't it? 690 revolutions. It means that 4.6 kilowatt power, if it is consumed for 1 hour time, it is going to make 690 revolutions, correct? Now keep the logic there. Don't use any formulas. Go with the plain mind. Okay, you are engineer. Think like an engineer. So 1 kilowatt power, right, in 1 hour means how much it will be now. So from here to here, how you will going to come? Divide this 4.6 with the 4.6. 4.6 with the 4.6, then you will get 1 point. So that means here also you have to divide this value with the 4.6 here. Clear? If you divide that with the 4.6, how much you will going to get? 690 divided by 4.6 here. Of course, you will be getting simply like 150 revolutions here. Clear? 150 revolutions. Then what would be the answer that you got here finally? The magic here is we have not used any formula. Finally, it is coming like 1 kilowatt power. If you consume for 1 hour, the meter has a capacity to make how much here? Meter has a capacity to make 150 revolutions. Therefore, how do we define the meter constant here? Any one of you? There are 15 students are there. Please let me know. What is the meter constant ultimately here? Clemendo is given some answer. Very good. So finally, the meter constant could be written as equal to 150 revolutions. Meter constant can be written as 150 revolutions per kilowatt hour. Clear? That's why it is called as a watt hour meter. See, now we have not used any formula. Directly we understood this one. Many of the students, they argue with me, sir, if we use the formula, then we can complete the question so fast. My intention is, how many formulas you will remember when you go through 12 subjects, correct? It is always better to go with the basic like this, so that any question you can answer. Now I will show you some questions where if you go with only formula, you will not be able to answer. The best is this one. You look at this one. You look at this question now. I'm asking to Rajshekhar, Isha Agarwala, Soumya Bala and Gurumurthy, Mystery Mind, Clement Aldo. So please answer this question. This is very interesting. If you go with the formula, it takes a lot of time. Now let me answer the question here. 230 volt, 10 ampere. One second. 230 volt, 10 ampere, single phase energy meter makes 90 revolutions in 3 minutes. Look at that. 90 revolutions in 3 minutes at a half load. Good, right? So the rated voltage and unity power factor. Good. So if the meter constant is 900 revolutions per kilowatt hour, right? So now let us try to understand. So I think it is not 900, it is 1800. It must be 1800. There is a small mistake here. It must be 1800. Now if you go with the formula, there is a problem here. Then try to solve intellectually and get me the answer. How do we solve this one? First calculate the total power here. Total power, if you look at what was given here, 230 volt here, 230 volt into 10 ampere here, right? And he was saying that at a half load. So 10 ampere is a rated one. So half load means how much it will be now? Half load means I should say this is equal to 10 by 2. Clear? 10 by 2 into cos phi. What is cos phi value? Cos phi is equal to unity power factor. So it is equal to 1. Why I took 10 by 2? Because he told that at half load. At half load. Right now the total power would be written as equal to 230 into 5 simply. What is its value here now? Can you tell me? Yes, 1150. Very good, Clemento. So 1150 watt here. In fact, it is actually nothing but 1.15 kilowatt. 1.15 kilowatt is the total power here. Good. So stay there itself. Now he is saying that it is able to make 90 revolutions in 3 minutes. 90 revolutions in 3 minutes. If it is going with that, right? So let us see. Now 90 revolutions it is making in 3 minutes of time. Good. Let us call this one like this. All of you please see here. So what is that? 90 revolutions in 3 minutes. 3 minutes of time. 3 minutes of time. It is making 90 revolutions after consuming a power of how much? After consuming a power of 1.15 kilowatt here. 1.15 kilowatt. Now can you tell me 1.15 kilowatt power, if it consumes for 60 minutes, what will going to happen here? 60 minutes is actually nothing but 1 hour time, right? So that means 20 times we need to multiply. So what you will going to get here? 20 times if you multiply, I am very sure, because 3 minutes 19 revolutions means 60 minutes how much it is. So with 20 you need to multiply. 20 into 90 I need to multiply. So it will come like 1800 revolutions. Good, very good. Right? So 1800 revolutions. Excellent. There is no issue. 1800 revolutions. But that is for 1.15 kilowatt. Isn't it? Then for 1 kilowatt, how much this will be here? Clear? 1 kilowatt, how many revolutions it will going to make? Any one of you please tell me here. Right? Can you guess what is going to be the answer here? So for 1 kilowatt, how much it will going to make? So simple here. So 1.15 kilowatt can turn 1800 revolutions, means 1 kilowatt can turn how much here? Simple logic, 1800 divided by 1.15 here. So how much it will be? So again I will repeat, 1800 divided by 1.15. Without any doubt I can say its value is equal to, can you guess or can you get it? Soumya Bala, what is the value here now? Its value is equal to 15652 revolutions approximately, correct? 1565.2 revolutions it can complete in if it is consuming 1 kilowatt. That is what the present situation. It is the present situation. Okay, present situation. But really speaking, according to the motor constant or meter constant, 1800 revolutions per kilowatt at half load, or what is say like at half load. Clear? At half load. This is what I told to you, correct? So that means according to meter constant, what meter constant is saying? At a half load only, if you consume 1 kilowatt power, if you consume 1 kilowatt at half load only, for 1 hour time, the meter constant is saying that you need to make 1800 revolutions. Clear? This is what the meter constant and its calibration is saying. Meter constant is saying that. But when I use this in my home, it is actually showing 1565.2 revolution per 1 kilowatt power consumption. That means I should agree with the fact that this is the ideal one. This is the ideal one. Correct? Ideal means we call this as a true value. Correct? What is the measured value here? Measured value is this one. Right? Now you tell me, if it is consuming 1 kilowatt, actually it should show 1800 revolutions. But how much it is showing? 1565.2 revolutions it is showing. Now tell me, is the meter is running fast or slow? Soumya Bala, Clement, Aldo, tell me whether the meter is running fast or slow. Meter is running fast or slow? I should say it is actually running slow. Correct? It is running slow. Correct? Because it has to indicate 1800 revolutions, but it is actually making 1565.2 revolutions. Slow. Slow is the answer. But how much slow it is? Because they are asking percentage of error, right? So how do you get the percentage here? Simple, measured value minus true value divided by true value into 100. If you do this, you will going to get the percentage. How much it will be here? Soumya Bala, anyone answer? Very good. So 4 students are giving good answers. Okay, please see here. Let me write down 1565.2 minus 1800. Okay, so you got some value divided by 1800. Of course, it is coming something around this into 100. So my calculator is showing it as a 13.04 minus 13.04 or 13.04 slow. This is correct. Okay, option B is the correct answer for this question. Now tell me, every one of you, this question is very popular. Even this kind of questions are so popular in the GATE examination. Did I use any formula here? Both of you tell me, Soumya Bal and Aldo. Both of you tell me, did I use any formula here? I have not used any formula, correct? I have not used any formula, but even then we got the correct answers. How does it is? It is the power of the basics. You have to know, you should know how to use the basics instead of remembering so many formulas. If you refer the textbook, of course there will be so many formulas, correct? But if you go in this way, you don't require the formula. The crazy point is here, 3 minutes 90 revolution means fix the power and go for 1 hour, right? Then look at for 1 kilowatt, how much it will go into, because time is fixed now. Clear? That is how we can do here. Now moving ahead to the next question. This is a little bit good question only, I guess. Let me see what is the range of or standard of this question. So the number of revolutions for 230 volt 20 ampere watt hour meter is 1000. Okay. Test at half load resulted 40 revolutions in 62 seconds. The meter error at half load is dash. Meter error at half load is dash. Clear? So now what we should do is, first of all, try to identify what is the meter constant here. So 230 volt into 20. So what is the total power here? P total is equal to 230 volt into 20 ampere current into power factor is not mentioned, means we will take 1. Right? How much it would be here? So it will be like a 4600 watt. Correct? 4600 watt. Right? So 4600 watt. Very good. So maybe they are taking the test at half load only. Test at half load, they are getting the 1000 here. So that means it might be the total rated power, but at a half load, what will be the power consumption? PT can be written as how much here? Half of that is nothing but 2300 watts here. So let me write down like this. Clear? And fortunately, it has to show 1000 watt power. Clear? So maybe we don't know what is the time. So therefore, I should consider that 2300 watt in 1 hour time only. It should actually make how much? 1000. This is a standard version. Clear? This is the standard version. Now let us see what is given here is at the same half load, fortunately the disk is making 40 revolutions in 62 seconds. What does it mean? Let us say 62 seconds it is making 40 revolutions. Clear? 40 revolutions. This is the true value. So in fact, this is the true value. Whatever we are using here, these are the true values here. But what is the situation here? It is a situation right now 62 seconds it is taking to show, or in 62 seconds it is making 40 revolutions. Relax. Try to estimate for 1 second how much it would be. 1 second it would be 40 divided by 62 revolutions. Clear? Then look at for 3600 seconds, which is called as 1 hour time, and look at how many revolutions it is going to make now. So 3600 revolutions, correct? So therefore I can say 3600 into 40 divided by 62 revolutions. Can you tell me what is that number here? Right? What is the number here? 3600 into 40, of course that is divided by 62 here. So I got something like 2322.58. Clear? So therefore I could say this is equal to 2322.58 revolutions I can say, and that is for 1 hour time here. Clear? 1 hour time, right? So now 2322.58 revolutions it is making, right, in 1 hour time. So 2322.58 revolution means this corresponds to how much power? Can you guess here? What would be the expected power here? Have you remembered that if it is making 1000 revolutions here, I can say the power consumption is 2300. But right now it is making 2322.58 revolution. What would be the power that it is going to show to you? Clear? So what is the power it will going to show to you now? So it will show the power, because 1000 revolutions this much means that will going to become how much power here, correct? So therefore how can I write this one now? 2322.58 into 2300, that will be some value, divided by obviously like 1000 here. So therefore it would be like here 5341.9 watts here. Look at that, whether this is correct or not. Every one of you, yes, very good, 5341.9. So this is the indicated power now, correct? This is the true value. This is all about true value. But here this is the indicated value, or we can say measured value here. Clear? So such a high value it is. Measured value is too high here, correct? So it's very high value, right? So now we have measured value, we have true value, then you can calculate the error at the half load. Error at half load, because as the question is asked about only error at half load, so it is very easy. Finally you can get the error as equal to how much? Measured value minus true value. Simple. Clear? So Soumya Bal, is it okay so far? Every one of you must answer here. Is it okay or not? Because at a half load, this is what it should be happening. That means 2300 watt if it is consuming in 1 hour time, it should make 1000 revolutions. But here in 1 hour time, it is actually showing so many revolutions here. Why? Because it is actually looking at the power. How much that is? As 5341.9 watt. Clear? Soumya Bal, is it okay? Got the idea? And Aldo, please tell me here. Or am I moving fast? You must answer clearly. Okay, right. So now let's move on to the next question here. This question is simple only. I will leave this for the homework here. So please try to do from your side here. Yes, very good. So the disk of a house service energy meter, it is 230 volt, 1, 5 ampere, means power factor is 1. Power factor is 1, 5 ampere, this is power factor. Unity power factor 5 ampere, 2400 revolutions per kilowatt. In fact, this is a meter constant. He has given the meter constant. Good. Creeps at 1 revolutions per minute. The creeping error at full load and unity power factor is dash. So what do you mean by creeping error first? Creeping error is nothing but when we don't connect any load. When we don't connect any load, or else even if the load is not consuming any power, the disk will going to make a small rotations. That's why it is called as a creeping. Creeping means it's like a crawling, right? So that means even though there is no power consumption, the disk will slowly rotate inside the brake magnet. So that slow rotation is called as a creeping. So how many revolutions you are going to get? That is the power indication, correct? That is error only. Actually, when there is no power consumption, if no power consumed, then what should happen? Then number of revolutions. Let me write down, number of revolutions must be equal to 0, correct? So suppose if there is no power consumed, if the number of revolutions is equal to 5, then the error will be power related to that 5 revolutions. Power related to that 5 revolutions. Now look, see what he is saying. This is the ideal situation. Clear? This is the ideal case. Let me write down. Ideally, this should happen like this. But let us see what happened here. What happened here is, he is saying that at creeping error means when there is no power consumed by the load, or else when everything is switched off, power consumption is 0, it is making 1 revolutions per minute. Means 1 minute it is making 1 revolutions. Good. So then 60 minutes, how much it will going to make? 60 minutes means it is going to be of 1 hour time. In 1 hour time, 60 minutes, how many revolutions it will going to make? 60 revolutions it is going to make. Correct? It's making 60 revolutions here. Now apply your common sense. Clear? So in 1 hour time it can make 60 revolutions. So this corresponds to how much power here. Clear? Can you get what is the power of this? So to get that power consumption, now again we need to use the meter constant here. What was the meter constant? Meter constant is saying that if you consume 1 kilowatt power in 1 hour time, it is actually means that it will make 2400 revolutions. Correct? But in the same 1 hour time, it is making very slow rotation of 60 revolutions only because of creeping. It is creeping, right? Because of even 1 hour time, it is just able to make only 60 revolutions because of creeping. Why? The power consumption is low. How much it is low, right? That means I will write here itself. 60 revolutions it is making, right? In same 1 hour only. Then what would be the power here? Clear? Now Soumyabal and Clemendo and Isha Agarwal and even Rajshekhar, please let me know what is the answer. Excellent, Aldo. Nice. Very good. So I think you enjoyed today's topic. Aldo, tell me whether you have enjoyed the topic or not. So this is going to be just only 25. Clear? It is just only 25 watt. It is not kilowatt. It is 25 watt. So in fact, this is going to be 1000 watt here. Correct? So this is in turn we can say it is nothing but 1000 watt. 1 kilowatt is nothing but 1000 watt. Right? So now it means that 25 watt it is actually consuming, that is a low power during the creeping side, and it is making 60 revolutions. Honestly speaking, it will not consume any power. Why? There is no power consumed by the load. It is switched off. Ideally, it should make 0 revolution. Correct? Because the power consumed is how much? Ideally, the true power consumed here is equal to 0 watt. But as the disk is making 60 revolutions, because of creeping in 1 hour time, it shows that the power consumed is 25 watt. Clear? It shows that power consumed is 25 watt. That means true value of power, here it is equal to 0 watt. But the reading from the disk will indicate the measured value here. Let me write down. Measured value of the power because of this small creeping of the disk is going to be equal to 25 watt. Clear? Then what is the error now? Soumyabal, this is a good question. What is the error now? Now the error would be written so simply as equal to dash. Again same, measured value minus true value, which is equal to 25 watt minus 0 watt. Obviously that is equal to 25 watt. Clear? 25 watt. Therefore I can say the value, finally the value of the error is going to be 25 watt. Means really speaking, there is no power consumed by the load here, but because of the small rotations made by the disk, it is equivalent to indicated value of 25 watt. Clear? So hope you understood this question. Soumyabal, is it clear to you? Because you are not responding to this question. Or any doubt here, or is it clear? So please tell me here. Yes. Okay, good. So 25 watt is the correct answer for this question, and that is called as a creeping error. Now moving ahead to the next question. Of course, already I have informed about this one, right? So I told you about this point. That is, in case of wattmeter, pressure coil or potential coil must be highly resistive. But in case of energy meter, the pressure coil must be highly inductive. Clear? It should be highly inductive. Pressure coil or potential coil must be highly inductive here compared to wattmeter. In wattmeter, pressure coil should be highly resistive. In energy meter, pressure coil must be highly inductive. Clear? So this is the most popular question. Many times I have seen even in the PSUs and BARC exam about this question. And if you want to know what is the background proof of this, I sincerely suggest please visit my lectures in Byjus exam prep app. You can download the app and you can view the measurements lectures In that, in energy meter, I have explained what is the reason why the pressure coil must be inductive in energy meter. What will happen if it is not inductive? That also I have explained. Okay. So generally, in ideal situation, if pressure coil is highly inductive, pressure coil is highly inductive, then the power measured will be equal to how much? Then the power should be written as, or power measured is equal to Vi into cos phi. This is simple, Vi into cos phi. So if at all, look at this very, very important point here, because these things are at most important here, right? If pressure coil is highly inductive, what is the angle between the phase voltage and pressure coil current? Anyone of you? The angle between supply voltage and pressure coil current is equal to how much? Pressure coil current equal to 90 degrees. Clear? This is going to be 90 degrees. So simple, right? Because if it is highly inductive, then the current through the pressure coil will lag the voltage by 90 degrees. Simple. Suppose if I say this is a pressure coil here, look at that pressure coil, and I am saying highly inductive, and just connect a single phase supply to you. Single phase supply here. Suppose if I connect a single phase supply at steady state, what will going to happen if I say this is voltage here? So let us say this is VI phasor, and this is VI phasor, and this is IL phasor. Now you must understand the current which is going to the pressure coil will lag the voltage by 90 degrees. That's why I mentioned that it is 90 degrees. Clear? So now one must really understand what happens if it is not the case. That means if the angle, or else if the pressure coil is not highly inductive, assume that pressure coil is not highly inductive. If pressure coil is not highly inductive, if it is not highly inductive, let me tell you what is the problem here. If it is not highly inductive, then I am very sure there exists an angle difference, right? The angle between supply voltage phasor, and look at that, supply voltage and pressure coil current. Pressure coil, or we can say potential coil, both are correct only, right? So that will be equal to some angle, we can say delta here, whatever it may be, it delta. So let me write down delta is the angle that exists between the supply voltage and pressure coil. If this is the case, then people do say that the power that we are going to measure here, it would be equal to Vi into sine delta minus phi, and phi is the lagging. In fact, it is the phi is the angle created by the load here. Clear? Phi is the angle created by the load. Now you must understand this is exactly what will going to happen if the coil is not inductive, but if the coil is highly inductive, this is what we will going to get, and we require this one. But in case if it is not highly inductive, then this will going to happen. Now you can see, suppose if I make delta is equal to 90, if I keep delta is equal to 90, what will going to happen? If I keep delta value is equal to 90, you can substitute 90 here. So sine 90 minus phi, it will going to become cos phi. Clear? Then you will going to get this one. So this means you must be very clear and clever. If it is highly inductive, only one thing we need to do is keep delta is equal to 90. If you keep delta is equal to 90, this expression will going to become this expression. Simple. So therefore, moving ahead, what should I say? Or let me keep one question here for you. The voltage flux adjustment of a certain single phase 220 volt induction type wattmeter is altered so that the phase angle between the applied voltage and the flux due to it is 85 degrees. Clear? So that means voltage and flux, you can say this as a flux or current, because the current and flux both will be on the same vector. Clear? Current and flux both will be on the same vector. So both in phase, current and flux will be in phase. So therefore 85 degree it is. What does it mean? Delta is given like 85 degrees here. Good. And so the error is introduced in the readings of this meter when the current is 5 ampere at a power factor of unity. So current is given like 5 ampere, power factor is unity. So power factor is unity means what? So power factor I can say which is equal to cos phi, and especially they are saying that it is unity, therefore it is equal to 0. Correct? It is equal to 0. Then what is the true power? True power PT. So let me write down P true value. How can I say this one? This is equal to VI into cos phi, isn't it? So VI into cos phi, how much that will be? It is equal to 220 volt into phi into cos phi is 1. So this will be equal to how much? Can you tell me here? Soumyabal, what is the answer here? So 220 into phi. So it will be coming like 1100. In turn, I should say 1100 means 1.1 kilowatt here. Clear? So that is the true value of the power. But it is possible only when the angle between the supply voltage and the flux in the pressure coil, if both of these two are at 90 degrees angle. Correct? But what he is saying, right now it is at 85 degrees. So what should I say? The measured power now, what I told you earlier. So if the angle is not 90, or even if the pressure coil is not highly inductive, we must use this formula. Correct? So some answer is given here, minus 4.185. So let's see. So that is V into I into now V into I. Up to here that is correct only. So let me write down here V into I, and followed by that what? So it is going to be sine delta minus phi. Sine delta minus phi. So what is this now? Voltage 220 volt, and I, what is the current here? Current, where is the current? That is phi. Very good. Into sine of, look at that, 85 minus 0 here. Simple. How much you will be getting here? So can you please tell me what is the value of this one? 220 into 5 into sine 85 here. Let me write down sine 85. So this is coming down to be equal to 1095.8 kilowatt here. Oh, great. I think Soumyabal has given the final answer. Okay, very good. So this is measured value, right? So then what is the error here now? Now the error could be given as a measured value minus true value. Clear? How much that value will be? Measured value minus true value, I can say that is 1095.8 kilowatt approximately minus 1.1, that is 1100 kilowatt. So and if you do it properly, you will going to get 4.2 approximately. It will come like minus 4.2 kilowatt. This is the approximated value. Approximate value is minus 4.2 kilowatt. So the final answer for this question is minus 4.2 kilowatt. So I hope I have covered all different types of questions in energy meter along with the basic induction principle. Within 1 hour time, whatever I can do, I have done that. But at the same time, I request the people who want to master the basic physics behind the energy meter clearly, beautifully, intelligently, then you can refer my lectures in Byjus exam prep. There I have taken almost around 40 minutes only to explain the induction and the torque equation. What happens if the brake magnet is moving forward or going forward? How do we provide the damping? All those things were very well and clearly described. However, as far as the competitive exams are considered, whatever the type of questions that to be answered, I have explained all the questions. Hope you really enjoyed this one, right? This type of questions for the preparation of HPCL, more than sufficient. Although I should say what I have discussed today, especially in the energy meter, that is more than sufficient for HPCL examination. In HPCL, the questions will stop at the level of meter constant only. They will not go up to this level. This is usually the gate level. Clear? Hope you enjoyed with this. Of course, tomorrow's schedule again will be the same time at 9 p.m. We are going to meet together to discuss the concept of the Q meter. Don't miss the session. As all of you know, I will try to explain the concept by using the less number, very less number of formulas. So it will be an interactive section even tomorrow also. Clear? Right? Hope you really enjoyed. We'll meet tomorrow at 9 p.m. sharply to discuss the concept of the Q meter. Thank you very much.